This talk will be concentrating mainly on the topsoil layer, which is where most of the action happens. Includes mineral particles of various sizes, plus bits of undecomposed plants and other organic matter. Supplies oxygen to plant roots and the creatures that live in the soil. Includes dissolved chemicals and nutrients essential for plant growth. If one ignores the organic material, the rocks, the stones, and any bones buried by the dog, the solid bits in soil can be divided into 3 types, as shown. The International Convention for defining sand, silt, and clay is by particle size. And if you can't visualize how small these sizes are, here is a human hair for comparison. Both are virtually insoluble in water and contribute little to plant nutrition. In this magnified image, you can see that sand particles have irregular shapes, and so there are relatively large spaces between them. It's in the pores between the particles where it all happens. It's here that you will also find most of the humus and nutrients so important to the plants. Let us consider clay. As clay particles are extremely small, they are easily washed down between sand and silt particles. This is an atom. An atom becomes an ion if it gains or loses electrons. A single glass of water contains more atoms than there are grains of sand in the world. Salt is sodium chloride, NaCl. The chlorine atom steals an electron from the sodium atom. The chlorine atom changes to a chlorine ion, and the sodium atom becomes a sodium ion. The same thing happens to other salts in the soil. This is an electron microscope image of kaolinite. The width of this picture is about 1/4 the width of a human hair. Each particle carries a negative electrical charge. As a result, the colour of illite is a drab white or grey, whilst montmorillonite is reddish brown or pink. This is the important bit, how clay particles lock up water in the soil. Water molecules, H2O, basically carry no net electric charge. However, the hydrogen atoms, H2, are slightly positively charged, and oxygen atoms, O, slightly negative. Therefore, the hydrogen, or the positive end of the water molecules, attach themselves to the negatively charged surfaces of the clay particles. As the water is now stuck to the surface, it is not available to the plants. Kaolinite particles only carry a weak electric charge, and so the layer of water on their surfaces is thin. However, the electrical charge on illite and montmorillonite particles is far stronger, and they lock up a lot more water. Only 16 to 18% of trace elements in the soil are needed by plants. The mineral solids in soils are very rarely just sand or just clay. They are usually a mixture of particles of sand, silt, and clay. The type of soil affects the availability of water and air, both necessary for healthy plant growth. The increased number of clay particles tends to cement the sand and silt particles together in the subsoil layer You may have to do this in several places around your garden if your soil is variable. The results will give you some idea as to what you need to do to improve the texture of the soil to suit the types of plants that you want to grow. Generally, sandy soils are improved by the addition of compost. However, if your soil has a high percentage of clay, you may need to dig in some gypsum, clay breaker or sand, as well as compost. This is Doug's old garden in Grays Point, and was a steeply sloping block with shallow, sandy, well-drained soil over sandstone bedrock. This topsoil analysis is fairly typical of the local area. Doug's garden is typical of many in Sydney, with shallow soils and large areas of exposed rock surface. This steepness, coupled with the sandy nature of the soil, results in it being very well drained. However, as there is more high ground behind this garden, water continues to run through the soil in parts of the garden for some time after it has stopped raining. Over the years, this in-ground runoff has leached out many of the nutrients in the soil. There are also some semi-permanent damp areas that, in the past, have caused a few problems with plants that do not like wet feet. As they are formed on water-wash quartz sand, these soils are also nutrient deficient. The natural vegetation in the Sydney Basin has evolved to survive in these nutrient deficient soils, but many of the species that we plant evolved in areas with much higher nutrient requirements, in higher facility soils, often non-Australian natives. Thus, we often need to improve our soils to accommodate these species. These are the two soil groups affecting local plant communities that you'll most often hear about. These are the Wienermatta group, which are mainly shales, and Hawkesbury sandstone. There are many different soil types in the Sydney Basin, ranging from shallow, sandy heathland soils to the deep, humus-rich soils such as found in rainforest gullies. Hawkesbury sandstone is made up of thin layers of sandstone. Each layer was once sand, deposited during a flood. The separation between each layer is the result of the silt and organic matter that settled on top of the layer of sand between the floods. The weight of the overlaying layers of sand compressed the lower layers into the solid sandstone rock that we find today. These soils are acid because the salts have been leached out of them. The less soluble iron and aluminium has accumulated. Wienermatta shale soils are found throughout the Cumberland Plain and on ridgetops. They are known as Krasnozens, or red earth soils. This group has the widest distribution of any major suite of rocks in the Sydney Basin. They make up much of the Greater Blue Mountains, on the Pittwater Peninsula, where it underlays the endangered Pittwater spotted gum forest and covers a vast swathe of the Central Coast. Locally, if you visit the disused quarry opposite the southern entrance to Lady Carrington, you'll see the parent shale weathering to form this rich soil. Plants can be looked on as pumps. The heat from the sun evaporates the moisture from their leaves, which in turn lowers the internal pressure of the sap in the plant. As a result, the roots suck in moisture from the soil. This moisture contains the nutrients that the plant needs to grow, make repairs, and to produce flowers and fruit. Tall trees have to pump this water from deep underground to high in the sky. Nitrogen is responsible for the green colour in plant material. Just as we humans need calcium for strong teeth and bones, so too plants use calcium to provide structural support to cell walls. Some indicators of nutrient deficiency you may notice, generally showing first in the oldest leaves, are nitrogen deficiency, a general yellowing, stunting and premature maturity, and lack of potassium, scorched margins and spots surrounded by paler areas. We'll look at some of these in more detail. It's important that the water gets down deep into the soil, as this will encourage deep rooting. Light watering that only wets the surface layer encourages shallow root growth, and this can expose the roots to excessive heat levels and drying out in hot weather. A layer of mulch will help the soil retain the much needed moisture. However, as some mulches decompose, they can form a barrier that prevents the water that falls on the surface getting into the soil. This can be a serious problem in hot weather. If this is a problem in your backyard, break up the mulch layer with a hoe. Putting short lengths of plastic pipe in the ground around the drip line of your larger plants will let you pour water directly deep into the soil. As discussed earlier, quite a lot of moisture can be locked away by the clay particles. Soil within the root zone needs to be able to store as much water as possible, but also drain well enough so that aeration is quickly re-established after watering or rainfall. Plants grow best when they have a suitable balance of water and air in their root zones. Here is how to check your drainage. You may have to check the drainage in several places around your garden if your soil is variable. These results will tell you whether you should raise the garden bed, add more organic matter or sand to improve the drainage, make a pond, or just plant lots of bottle brushes that like wet feet. If you have well-drained sandy soil, loss of moisture due to excessive drainage can be reduced by digging in compost. This can dramatically reduce water loss if you have steeply sloping, shallow sandy soils on top of solid rock. Soils need good structure, with abundant pores and channels to allow the movement of the water and air needed by both the plants and all the creatures that live in the soil. It's the movement of water through the soil that sucks air into the spaces between the soil particles. In waterlogged or compacted soils, the lack of air, oxygen, changes the soil chemistry. Lack of oxygen promotes the locking up of some nutrients and robs the soil of nitrogen by promoting conversion of nitrates into nitrogen gas, which then escapes into the atmosphere. The health of the myriad of microbes, bacteria, insects, fungi, worms, grubs, and other forms of life that exist in the soil are essential prerequisites for ongoing healthy plant growth. Their main function is to convert vegetable matter and animal waste into a form that makes it available as nutrients that can be absorbed by the plants. Total weight of all the little creatures in the top 30 centimetres of the soil in an average garden is about 700 grams per square metre. The main workers are the microbes, protozoa and bacteria, and the worms. Microbes, as their name suggests, are very small. In a teaspoonful of soil, you will find more than 1 million microorganisms, and there can be thousands of different species of them. Although you cannot see them, you may be able to smell them. Other microbes stop the soil from having a bad egg smell, whilst others protect the plants from soil-borne diseases. The star of the soil world must be the earthworm. In a worm-friendly garden, this can add up to about 7 kilos of high-grade manure per square metre per year, all of which greatly improves the fertility of the soil. Did you know that worms have 5 hearts? Over 95% of bugs are really helpful, and without them beavering away underground, all our plants would quickly die. If that happened, all life on Earth, including us, would die too. Tardigrades are known to be able to go for decades without food or water. They can survive temperatures from near absolute zero to well above the boiling point of water, to survive pressures from near zero in space to well above that of ocean floors, and to survive direct exposure to dangerous radiations. Some fungi eat wood, whilst others recycle nutrients. These fungi also protect the plants from disease and boost their growth by the secretion of natural growth hormones. Phytophthora, whilst not strictly a fungus, is similar in both morphology and habitat, but is actually a genus of plant-damaging oomycetes. If you must use fertilizers, stick to cow manure, blood and bone, and seaweed extracts. With climate change expected to result in big changes to rainfall amounts and distribution, droughts are predicted to become more common and last for longer. This is the colour spectrum that we can see of visible light. When the temperature in your compost bin gets too high, the worms move out. These are actual maximum temperatures, as recorded in Doug's garden, on Sunday 8th of February, back in 2015. Due to daylight saving, the sun was at its highest at about 1 o'clock. Deep water your plants to get the roots developing away from the potentially hot surface layer. Put some stones in the bottom of the pot to encourage airflow under the inner pot. Raising the outer pot on pot feet allows cooler air to enter the space between the pots. Always cover the surface of the soil in the pot with mulch. White gravel is recommended, as this reflects the most heat. The water vapour is produced by the heat of the fire, boiling off the moisture in the ground and in the plants. As it rises, the water vapour cools and condenses back to water droplets that combine with the CO2 to form carbonic acid, and this falls as acid rain. The smoke is mainly made up of very small carbon particles that fall back to Earth either due to gravity or by sticking to water droplets. The ash is washed into the soil and, for a short time at least, tends to cling to the pores between the soil particles. A common cause of nutrient unbalance is over-fertilizing. In acid sandy soils in high rainfall areas, the nutrient uptake by plants will be a great deal less. The nutrients available to plants change as the soil pH changes. Acid soils with a pH of less than 6 commonly have deficiencies in calcium, magnesium, phosphorus and potassium, whilst acid soils with a pH of less than 4 commonly have toxic amounts of both aluminium and manganese. In alkaline soils with a pH of more than 7, the following nutrients may be unavailable: iron, manganese, zinc, copper and boron. This diagram shows the pH range for typical soils, plus the pH of a number of common substances. The pH meter can be complicated to use correctly and to interpret the results. Do this very simple test, and if your soil does not fizz, then it's probably okay for growing plants. A reliable way to find out the pH of your soil is to use a test kit. Widely available from Bunnings or your local plant nursery, it will do multiple tests and should cost around $20. Simple. The plants that are native to the Sydney area are adapted to living in acid soils, so do not add lime to increase the pH. However, many vegetables originated from parts of the world with alkaline soils, so they tend to grow better in soils with a pH above 7. This is Grevillea eriostachya, yellow flame grevillea, growing in soil with a pH of about 7.5. And for 6 months of the year it doesn't rain in this part of WA. Many of the plants that are native to those areas do not thrive in the acid soils found in the east. This indicates a strong case for grafting plants from these areas onto local rootstock, and this species has been successfully grafted using Grevillea robusta as the rootstock. Plants don't actually grow in the soil, but rather in the spaces between the soil particles. So, make sure that your soil is well aerated, and worms will help you do this.